All right, today we're going to pull back the curtain on the hidden magic that powers pretty much our entire digital lives. We're diving into the clever thinking that makes some software feel lightning fast, and others, well, just frustratingly slow. Let's get into it. You've totally felt this, right? You click a button in one app, and bam, instant response. You do the same thing in another app, and you're just staring at a spinning wheel. What is going on there? Is it just your computer being slow? Not really. See, the real secret isn't about brute force or raw power. It's about being clever. It's all about how information is organized and used behind the scenes. The fastest, smoothest software is always built on a foundation of really elegant, efficient code. So yeah, this isn't some kind of dark art, that speed, that seamless feeling. It all comes down to intentional design using two of the most fundamental building blocks in all of computer science. And here they are, data structures and algorithms. The easiest way to think about it is like this. A data structure is your filing cabinet. It's how you choose to store and arrange all your information. An algorithm, then, is the recipe. It's the step-by-step instructions for how you find something, or add something, or take something out of that cabinet. So let's start with those filing cabinets, the data structures, because how you decide to store your data has a huge impact on how fast you can actually use it. And we're going to look at a super simple but surprisingly powerful example. Okay, check this out. This is a stack. And honestly, it works exactly like it sounds. Just picture a stack of plates at a buffet. You add a new clean plate to the top, and when you need one, you take a plate off the top. You'd never try to pull one out from the bottom, would you? That'd be a disaster. And that simple rule is everything here. That guiding principle has a name. Last in, first out, or LIFO for short. The very last plate you put on the stack is the very first one you take off. This structure is perfect for things like the undo button in your text editor. Think about it. The very last thing you typed is the first thing that gets undone. So the point is, the problem you're trying to solve tells you which data structure you should use. All right, so we've got our data neatly organized. Now we need the recipe, the algorithm, to actually do something useful with it. Let's look at something you have definitely used thousands of times, probably without even thinking about it. How in the world does a super long, clunky web address get magically transformed into a short, tidy little link? Well, it's not magic. It's just a really clever algorithm doing its thing. The process is actually brilliantly simple. First, that super long URL gets stored in a database and is given a unique number, like say 11,023,120. Then, an algorithm takes that big number and basically translates it into a different, more compact language. In this case, it's a process called base 62 encoding, which uses numbers 0 through 9, all the lowercase letters, and all the uppercase letters. This turns that giant number into a tiny little string like VHU2. And just like that, you have a short, unique, shareable link. So cool. Okay, so we've looked at a simple data structure and a simple algorithm. But what happens when you take these basic ideas and you scale them way, way up? Well, that's when you get the complex, interconnected digital world that we all live in. You know, at the heart of so many complex systems, from your social network to the GPS in your car, is a data structure called a graph. And its whole job, its entire reason for being, is to show how things are connected. And don't let the technical name fool you. A graph is just a collection of nodes, which are basically the items, and edges, which are just the lines connecting them. That's it. It's a really simple concept, but it has unbelievably powerful applications. I mean, just think about it for a second. On social media, the nodes are people, and the edges are the friendship connections between them. On a map, the nodes are intersections, and the edges are the roads that connect them. On the internet itself, the nodes are web pages, and the edges are the hyperlinks. This one single data structure, the graph, is literally modeling the fabric of our connected world. So we've touched on stacks and URL shorteners and graphs, but what's the big takeaway here? Why should any of us really care about how all this data is being organized and processed behind the scenes? It really all comes down to this. The quality of your digital experience, whether an app feels amazing and responsive or just clunky and slow, is a direct result of these deep, fundamental choices that developers make. It's the art and science of building something that just works. So let's wrap it up with the key points. Data structures are the containers, the filing cabinets that organize our information. Algorithms are the recipes that give us the step-by-step instructions on what to do with it. And when you put the right container together with the right recipe, you get fast, efficient, and really powerful software. And that brings us to the final thought I want to leave you with. Your entire digital life, from the news you see, to the route your GPS gives you, to the music it recommends next, it's all being shaped by these invisible structures and recipes. So the real question isn't just what they are, but what they're trying to achieve. Something to think about.